Welcome back, everybody. This is the first video of its kind like this on this channel, so bear with me. I want to go over something with the N55 BMW engine that seems to be driving a lot of people crazy when they're hitting about 100,000 miles, and that is their PCV system. They're either failing or they don't know if they failed and they don't really know how to diagnose it. The internet has a lot of good information, but it's not quite correct. Some of the stuff I've seen is not quite correct, and I'm going to go over that with you today. So for people who are new to the concept of this PCV or CCV system on this engine, I just want to go over that for you real quick before we get into it, because maybe there's something here you'll learn. If not, fast forward and skip this part. First thing is, this is my wife's car. It's a 2016 BMW X5. It's her favorite car in the world. She does not want to trade it in. She wants it to run and live as long as it possibly can, and we're about to hit 100,000 miles. I do all of my own work except for things that I can't do, like alignments, because I don't have the equipment. So I do most of my own work. And one of the things that tends to fail on this engine at this age is the PCV or CCV system, which is molded into the top of your valve cover. So this is the valve cover here. They run about 350 bucks if you were to do this yourself, several $1,000s if you had a dealer do it. And from what I'm finding online, it seems people might be doing this when it's not actually necessary. They think they have a failed system, but they actually may not, because the tests that you do to determine whether or not it's failed seem to be not very accurate. So I wasn't sure if we have a failed system. We do have rough starts every now and then and some rough idling that goes on, but a lot of things can cause that. So I didn't want to jump the gun and go tear the whole engine apart just to put in a new valve cover, because that's what you have to do on this engine. So the first thing that I've seen a lot of videos is you take this little decorative cover off here, and you take a lighter, and you light the lighter here and see if the flame gets sucked into the engine. It sounds super dangerous, but it doesn't seem to be. I've seen a lot of people do it. And that will tell you if the membrane inside here is broken. There's a rubber, very soft rubber membrane that sits inside this cover here. This cover can't be taken off unless you want to cut it. I've seen videos of people doing that. I just don't trust it. I'm not going to cut the top of it off and glue one on. If I was to replace this, I'd replace the whole thing the right way, because I just don't want it to break down because, you know, the glue cracks or something. This is, like I said, it's molded into the valve cover. It's meant to be replaced as a whole unit if you do replace it. However, I'd say this operates more like a natural gas pressure regulator. So what you've got is you've got vacuum, you're sucking air out of the crankcase, and then this membrane moves up and down to allow, there's a spring that the membrane hits, and that pushes on a valve that opens and closes, allowing more, or to relieve the vacuum, because as you rev your engine, you get more vacuum, and this thing regulates that so that your vacuum pressure maintains somewhat constant. Now, one of the tests, like I said, is to put a lighter here, and that will tell you if the membrane's broken, but that won't tell you if you have a stuck open or stuck closed PCV valve on the inside. There's no way, that will not tell you that. What you should see here is that membrane should be opening. It should kind of be going up and down, up and down, up and down as the engine changes speed, because the vacuum is changing, the pressure is changing, and that little membrane is allowing more air in or less air in to make up for that vacuum to maintain the proper pressure, which we'll go over that in a second, what that is. Another test I've seen people do is they'll pop open their oil cap, and they say, oh, it sucks the oil cap back on, so I must have a problem. Now I'm going to show you what mine looks like and sounds like so we can get that out of the way. Okay, I hope you guys can hear me all right. If you can, if not, I'll redo this with a voiceover. But here's the oil cap. I want you to hear what this sounds like. Let me get this dirt out of the way here. I want you to hear what this sounds like when I go to open this oil cap. I don't know if you can hear it, but it's sucking, and it's pulling the oil cap back on, and at times, when I do this, the engine will sputter if I take it off quickly. It's not doing it right now, but I guess when the engine warms up, it sputters when I take it off too quickly. Okay, you hear that suction? Okay. I've seen videos where people say that that is a symptom of a failed PCV system, and perhaps it is. Maybe if it's much, much worse than that, maybe your valve is stuck closed. But let me show you the test that I've come up with that's very inexpensive, and I'm going to explain what I mean by inexpensive in a minute here too. Okay, so I shut the engine off so you can hear me better. Here, hear that suction? I've also seen people say that if you have that happen after the engine is off, that you have something failed, and I don't believe that to be true either. So I'm going to show you. Now there's some oil that came out here because when I open the oil cap, it kind of splashes out while the engine's running. So let's do some quick math here. The hole is about 1.5 inches in diameter. So we're going to go ahead and figure out how much pressure there should be on that oil cap when you open it with the engine running. Okay, so I got a little bit of suction, there's a little suction on that oil cap when I pulled it off, and it didn't make the engine stutter, I guess, because it's not up to temperature yet, but when it is up to temperature, the engine actually stumbles a little bit when I pull that off, and people say that's a symptom of a bad CCV system, but I haven't found anybody who shows what a good system should do, and it would make sense that that would stutter because the intake air volume changes when you do that, because remember, there's a vacuum hose sucking in off of that crankcase and you're letting a lot more air in, so I would expect it to change the fuel to air ratio on the engine. In fact, doing that causes the check engine light to come on, and it does throw a MAF airflow. I think it's a MAF airflow sensor is what it shows. So anyway, here we go. Here's this chart that's in this service bulletin from BMW, and it shows all the engines that I guess have this closed system where you can't replace just the PCV valve, which would be great because they're about $5, right? But we can't do that here. And here we have what the pressures in these engines should be. You see the N55 engine should be 50 millibars plus or minus 8. We convert that to PSI, and we get, well, let's see, we have a 1.5 inch opening on our port there, our oil cap. So 1.5 over 2 gives us the radius. Pi r squared gives us 1.76 inches. And then we take, let me zoom in here. I don't know how clear this is going to be if I'm far away. So we got 1.76 inches. Then we've got our 0.725 psi, that's about 50 millibars, times 1.76, we get 1.28. So about a 1.25 pounds is what that should feel like when you pull that valve, that oil cap off. And that's kind of what it felt like. So what I found in this bulletin here is they show you how to test the pressure, the vacuum inside the crankcase using what I believe is a snap-on tool. Yeah, there's a diagnostic tool, and these look like oil caps that they just drilled a hole in it and put a port. So I said, all right, we can do that, and we can do it a lot cheaper. So let me show you how I came up with something that costs you about 18 bucks if you already have a manometer. The manometer is about 40 bucks, so maybe it'll cost you $60 to do this test. So this is what I came up with. Looks pretty straightforward, but let me walk you through how I made this. Because it's actually it's not quite as straightforward. If this was one giant chunk of plastic, it would have been a lot more straightforward. But let me show you. There were a few leaks, and I had to identify where the leaks were to make sure that it was, the air that this port was actually taking air from inside that O-ring right there and not from outside. I wasn't sure how this was molded. This is just a cheap aftermarket cap that I got on Amazon. So let me show you how I sealed it to make sure that the vacuum we're measuring is the correct vacuum. The correct spot. What I mean by the right spot, and I want to make sure that we're getting vacuum from the right spot, is I don't know what this is made of. I don't know if it's one giant piece of plastic. It obviously doesn't look like it is. And I want to make sure that we're not creating a vacuum leak by maybe having air leak out those edges there where you see there's a little bit of extra material there. This port came with the manometer, so it was essentially free, but you can pick these up at your hardware store. Nothing precise there. And then we're just going to drill a pilot hole in the center of the oil cap here to get started. I'm really trying not to crack this thing. I don't know if this is brittle plastic, so I want to step it up with pilot holes. So to choose the correct size drill bit, I just took an outer measurement here, just to be sure that the drill bit that I use is just a little bit smaller than the threads on there. I want to go ahead with another pilot hole, a little bit larger this time. Like I said, stepping it up so that we don't crack this. We don't want to ruin it and have to order another one. We only get one shot. And then here's our final drill bit, but in all reality, I should have used another drill bit in between this one and the last one because it was a little bit tough to not mess that up. Go ahead and check it, make sure it fits. Now keep in mind, there's not a whole lot of thread there, so we're going to have to, we can't use like Teflon tape on that. It wouldn't give us a good seal. Now we want to make sure that we don't have a vacuum leak. We want to make sure that this part where we connected that port is closed off to the rest of that cap, and it's not going to pull in vacuum from outside of the engine. We want to be measuring just the inside of the engine. So to do that, I'm using this brake bleeder tool, which you can pick up these at Home Depot, Lowe's, your auto parts store. And you can see we're not it's not drawing vacuum. You can see we definitely have a leak. So to figure out where the leak is at, you can see I really try hard here, and there's definitely we definitely have a leak. Absolutely a problem. So what I did was I just took shop air and some Windex, sprayed the bottom with Windex, and put some shop air in, and you can see it leaked around the entire outer edge. So that air was coming in from this edge right here, around the entire thing. So if you take out the rubber gasket, we're going to go ahead and we're going to seal that outer edge with some silicone sealant. Pretty simple. You want this to be a pretty flat surface when you're done so that you get a good seal when it's installed. So go ahead and take some Q-tips or some small pieces of paper towel. Try to clean it up nice so that you get a nice flat surface. And then once this is done, we're going to go ahead and check for pressure, check for vacuum again, and make sure we get vacuum before we punch a hole in the center of this lid. So to be completely sure that we weren't leaking around the edge of our threads there, I went ahead and epoxied this in place now. And I'm using the JB Weld. I've used this before for all sorts of gas projects that require gas-tight connections, and this will definitely do the trick. Like I said, you can't really use Teflon tape because the black plastic there is only, you know, a millimeter thick, and you're not going to get a good seal with any kind of sealant that I could think of. So I figured I'll just epoxy this on, and it actually looks like that's what they do to some of those caps in that document that I saw. My guess is they're using epoxy there. And that's what our finished product should look like. So I actually go ahead and I throw this in the oven at 100 degrees. We have a proof setting. Keep it in there for an hour so everything cures. Come back and do a quick pressure test. Might have been a couple hours actually. I left it in there because the silicone takes a while. Here we go again. We're going to reconnect it to the brake tool. And this time we're going to give it a shot, and you'll see we actually do get vacuum. So that's what I was looking for. I wanted to be 100% sure we didn't have any leaks in the cap itself before we drill the hole in the bottom of the cap, in the part where we're sure we're inside the crankcase. So there's this metal thing that kind of goes across the inside there, and you'll see I actually hit it with the drill here. If you watch the pressure gauge, right about here we lose pressure, right there, see that? So we actually punctured into the little cavity where the port is connected. That's a good thing. But I went ahead with a smaller drill bit to kind of go around that metal clasp that runs all the way through. So we get a very solid connection all the way into the crankcase. All right, so this is about a $40 manometer on Amazon. You don't have to use this one. You can get whatever you want that works within this range. I believe it was like -3 PSI to +3 PSI. We're just going to go ahead and hook up our port here. Everything obviously is dried and cured. And the way I cured this is I tossed it in the oven on proof. Laura loves when I do that. She finds random things in the oven. We have a proof setting that puts the oven at 100 degrees Fahrenheit. It's great for curing glues and silicones and epoxies and all that sort of thing. So, and also it's great when you put your keys in the washing machine. You throw them in there. A couple hours later, they dry out nice and they still work most of the time. All right, so I've got this on millibars so that we're working in the same units the whole time. I'm going to go ahead and swap out the factory oil cap, which I covered in oil by leaving it open while it was running, but you know, I'll clean that up later. Go ahead and put our tester on here. This is actually a good tool to just have. If you have one of these engines and you're at about 100,000 miles, just have it around. There's a good chance you're going to need it. Now, be very careful you don't start your engine and this falls in, because if it does, it's going to fall right into your serpentine belt. So you want to be careful that it's not in a place where it can fall. So let's see what we get with this engine, which I thought had a problem. I'll show you how I tested the vacuum leak here too, just to see if I had a broken membrane. I'm going to show you how I did that. That's more reliable than using fire. There are a lot of, like I said, a lot of videos where they take a torch or a little lighter and they put it here and they see if the fire gets sucked in, which does kind of seem dangerous. I don't know, but people say it's not. You can do a much better, more accurate test with a tube, a clear tube, and some engine oil, and I'll show you how that's done. But let's go ahead and start this up and see what we get and if we're in spec. All right, so the engine's been running about 10 seconds and it's starting to stabilize, and you can see we're at 48, 47, 48, right around that 50 millibar, definitely within the plus or minus 8 range, which is what they say in that document is appropriate. And like I said, so you can hear the engine RPMs are coming down. And as they go down, the vacuum lowers, but then the valve adjusts, and you can see we end up back around 50 again. And that's exactly how this system should be operating. So we have an absolutely perfectly operating PCV or CCV system in this car. So there's no need to replace this cover. So if you're diagnosing a rough idle at 100,000 miles, I would say this is the first thing you should do. And by the way, if you end up with a bad pressure vacuum system in this car, one of the first things that'll happen if that valve gets stuck closed is it'll start sucking air in through the crankcase seals or the crankshaft seals, and it'll damage your crankshaft seals, which is a fortune to get that fixed. So let me shut this off and I'll show you a quick shot of how I tested this using oil instead of fire. Okay, for this test we're going to go ahead and take off this little decorative cover here. And like I said, this is the top half of, I don't really know how to describe it the best. If you're not familiar with how gas regulators work, basically there's a membrane that pushes on a spring, and on the other side of that membrane, as it goes up and down, you have to, if you had this was sealed off, which could be, by the way, check for mud wasps and that sort of thing, because if that's clogged, you would have a problem. But if that were sealed off, then the membrane couldn't go up and down, which would make it not function properly. So they have a little hole, a little breather hole, so that as the membrane comes up, it pushes air out. As it goes down, it sucks air in. So what we'd expect to see on a healthy system is if I take a hose and connect it to that little port right there, this should suck up a little oil and then push it back a little, and kind of, as the pressure changes in the system, it should move the oil up and down this hose a little, but not suck the oil in. If oil gets sucked in, then you know you have a broken membrane and it's pulling in at that 50, negative 50 millibars. So I have a piece of irrigation hose here that I have from a drip line, but it's not clear, but it did fit inside this other clear hose that I had. So that gives me a nice seal. So I'm going to go ahead and do now is I'm going to go and put this into this cup of oil here, and I'm going to go start the engine, and I'll show you what I mean. It's not going to drink the oil because this is a functioning system, but we'll see. I'll show you what we should see on a good system. And be very careful that you don't let that hose fall down in there either. You don't want anything falling down there. All right, so if I take this hose and I put it in here, if I had a broken membrane, that would be sucking oil into there pretty rapidly. So now what you're going to see is it should push out a little oil, and it should pull in oil, and it should kind of just go up and down as that regulator needs it, needs air on the back end of it. And you can see that's exactly what's happening. You got it. It's a little blurry. I don't know why this camera is not behaving today. There you have it. See, it sucked up a little, puts down a little, sucks up a little, puts down a little. So this is a perfectly functioning valve. Nothing's wrong with it. And now we've tested that the membrane's good. We've tested that the pressure in the crankcase is good. There's absolutely nothing wrong with this system. All right, so now we know we have nothing wrong with this. We can go chase down our rough idle somewhere else. The next thing I'm going to try is to replace the spark plugs. And like I said, it's not rough all the time. So it has original spark plugs, original coils. Coils, they don't seem to be the problem. My guess is new spark plugs wouldn't hurt anything, so might as well do it. And the other thing that I'm going to be investigating is the charge pipe does have a little bit of oil leaking out from underneath of it. So over here we have a little bit of oil there, which maybe there's a boost leak. Maybe that's part of the problem. Maybe the throttle body's dirty. We're going to find out. But the point of this video was to show you how I tested my PCV system to make sure that my crankcase pressure was good. Hope this helps somebody out. Like I said, maybe 60 bucks, maybe 20, depending on what tools you already have. And definitely worth having on hand if you have one of these engines, because if that fails, you're going to be talking lots of money to fix these seals if it starts sucking in air somewhere else. Let me know what you guys think of this video. Like, comment, all the things. Comment down below if this was helpful. If you've already done this test, I'd love to hear about it. Love to hear if you have any other ideas too.